Hello guys, Assalamu alaikum. My name is Mohammad Murtaza. I'm here teaching you physics, and in this video we will discuss about the topic, you may say the heading, scalars and vectors. What is the secret behind those? How you can understand scalars and vectors. If you are new to my channel, so please subscribe it. If you already viewing my videos, then please like my video. Also press the notification bell icon so that you may also receive much more of my videos. Let's get started. Before going into the topic of scalars and vectors, I must say you that you should all watch this video till the end, from the beginning till the end, because it's most important. I will give you some important points of physics, the basics of physics, and that will lead us to scalars and vectors. So if you are hoping that you will understand what are scalars and what are vectors, you should watch from the start till the end. Let's get straight into the topic. Okay, for the first I will teach you what is quantity. Actually, what are quantities? Let's say this board which you are seeing. This board contains atoms, billion, trillions and quadrillion, many more that are uncountable atoms. This board also contains molecules. This board also contains ions. This board is basically a matter. So a matter is basically called quantities. So this board is a quantity. Look at yourself or look at me. I am a human body. My body contains cells, tissues, many organisms, and much more about these. So all of those are quantities. You see your cupboard. You see this marker. This marker contains atoms tightly packed, molecules, ions, and the atoms and molecules together combine to form a quantities. So the whole universe basically counts quantities. They are all made up of quantities, and the whole universe is a quantity. You cannot say that this is not a quantity, this is a quantity. No. Everything in this universe, everything in this world, everything in this universe is made up of entirely all quantities. These are all quantities. So in this video I will discuss these quantities, and while discussing these quantities we will get straight into scalars and vectors. Okay, these quantities are divided into two sub quantities. Number one is physical quantities, and number two is non-physical quantities. When a person, when a baby, when anybody is born, our God gave us 5 senses. What are those? We can touch anything, this is one sense. We can smell anything, this is second. We can listen anything, third. We can taste anything, fourth. And we can smell anything, 5 senses. So these are basically the 5 senses that God has made with us, so that we can do anything whatever we want. We can eat food, we can talk to each other, we can listen many things, and we can do much more anything else. So basically God has provided us 5 senses, human senses you can say. Okay, first let's consider this marker. I can touch this marker. I'm holding this marker, so I'm touching this marker. If you want, you can lick the marker. If you can touch the marker, means you can observe this marker with one sense. I can also lick this marker, but I will not, because I feel a little bit shy. So when I can lick this marker, so it means that this marker can be judged, can be observed by 2 senses. I'm watching this marker, so I can observe this marker with 3 senses. And you know what? I can smell it. So 4 senses. So in another way you can say I can observe this marker, I can judge this marker by 4 human senses. For example, let's say this is a board. This board, you can see it. It means you can observe this board by 1 sense. I can touch the board. So I can observe this board by watching and also touching. So means I can observe this by two senses. You may want to, so I can lick, but as I said, I am a little bit shy. So three senses. If you want, I can smell it. Four senses. It means that this board can be observed by four senses, maybe five senses. For example, let's consider a table, and on the table is a plate on which a burger is placed. So burger is on the table and you are watching this burger. It means you can observe this burger by watching. You can observe this burger by smelling. You can observe this burger by touching. You can observe this burger by eating. So four senses. You can observe this burger by four senses, four human senses. It means that, now listen to the definition. Anything that can be observed by our human senses. It may be all of the five, it may be only four senses, it may be three, it may be two, it may be one. So if anything can be observed by only one sense or more than one sense, then this quantity is known as physical quantity. Let's say it again. If any quantity is measured, can be observed by using five senses, five human senses, then this quantity is called physical quantity. For example, marker. For example, board. For example, burger. There are infinite quantities in the world which can be observed by our five senses. Let's get straight into it. What are non-physical quantities? Non-physical quantities. The quantities which cannot be observed by any of sense. You mean there are five senses in the human? If a human cannot observe a thing by using five senses, then this quantity is called non-physical quantity. Let me give you an example, it will clear you much. For example, let's say I said to a kid that please bring an atom in your hand, calculate its mass, calculate its volume, and calculate its density in front of me. This student will stand up and he will say, how is it possible? I cannot even touch the atom. I cannot even smell the atom. I cannot even see the atom. I cannot even listen the atom. And observe, I cannot even taste the atom. So the atom is the quantity which cannot be observed by any of the sense. You cannot see the atom, you cannot smell the atom, you cannot eat the atom, you cannot touch the atom, and observe, you cannot listen the atom. So this atom cannot be judged by any of our five senses. That's why it is called non-physical quantity. So in physics, remember, in physics we will always discuss physical quantities, not non-physical quantities. So we are discussing physics, let's erase the non-physical quantities and let's start with physical quantities. What are physical quantities? Alright, what are physical quantities? I have already told you, the quantities which can be observed by our five senses are called physical quantity. Simple definition. Okay, a physical quantity, let's assume this is a person, this is a man. So you can see the man, it means he's a physical quantity. You can touch it, you can do whatever you want. I mean, you can taste also, but it's a little bit shy. So let's assume this is a person and he is a physical quantity. This physical quantity, if I say to you that please measure the length of this person, you can measure. You say that the length of this man is 10 meter. For example, no person is here that is being 10 meter in the world except for very old ones. So let's assume that this man is 10 meter high. This man is 10 meter, you say tall. you have measured the length of this physical quantity. Okay, now I say let's measure the mass of this person. You say this person is 60 kg. The mass of this person is 60 kg. It means that you have measured the mass of physical quantity. Am I correct? It's nothing big. It's nothing very confusing. I am only measuring the length of the physical quantity and mass of the physical quantity. Let's say this person is on the track, on a race track. This race track begins with point A and ends in point B. And person runs from A to B and he take 10 seconds to cover this distance. So you can measure the time of this physical quantity. So let's see. You can measure the length of this physical quantity, you can measure the mass of this physical quantity, and you can measure the time of this physical quantity. So any quantities, these three, length, mass and time, are known as quantities. But which quantities? Let's define it. Any quantity which are used to measure physical quantity. Look, the length is measuring the person's height. It means the length is measuring the physical quantity. The mass is measuring the person's weight. It means the mass is measuring the physical quantity. You can measure the time of the physical quantity because you are measuring the time of this person. So that is why you can measure the time, you can measure the length, and you can measure the mass of this physical quantity. So any quantity which is used to measure physical quantities are known as fundamental quantities. You may get the definition of it. If you have any problem in my lecture, you can comment below. I will try my best to make a new video about it. Okay, let's start. These are the three fundamental quantities which were known in 11th century. These three fundamental quantities have been discovered in 11th century, and after time has passed, time begins to travel more and more. The new quantity, electric current, new quantity, temperature, new quantity, you can say luminous intensity, and amount of substance. So as the time has passed, many more fundamental quantities have been discovered. In SI units, the length is measured in terms of meter, the mass is measured in terms of kilogram, the time is measured in terms of second, the current is measured in terms of ampere, the temperature is measured in terms of Kelvin, the luminous intensity is measured in terms of candela, and amount of substance is measured in terms of mole. So these are the units of fundamental quantity, and these are fundamental quantities. So we have cleared the definition that the quantities which are used to measure physical quantities are known as fundamental quantities. Okay, now we will get straight into scalars and vectors. The physical quantities can be divided into two more quantities. First are scalars, and the second is vector. What are scalars and what are vectors? Let's remove the s from them. Now you can say that this is a scalar quantity, this is a vector quantity. If you divide the physical quantity into two branches, the first branch will be called scalar and the other branch will be called vector. Let's define what are scalar and what is vector. Okay, let's suppose that this is a bag. You can say in this bag there is lot of water. and let's assume this is a water which has a mass of, let's assume it 10 kg. In this bag 10 kg water is present. Okay, any problem? There is no confusing in it, because this is just a bag, it contains 10 kg water. If I question you, what is the direction of 10 kg? I'm questioning you, what is the direction of 10 kg? You may answer, but you will not answer, but you will say another excuse that what kind of question is that? How can it possibly having a direction? A 10 kg water having a direction? Are you sure? Are you serious? Are you gone mental? People will say that because it is an illogical question. You know, this is a 10 kg water. Let's define what is 10 and what is kg. 10 is called magnitude. Kg is called nature. Kg is called unit. Okay, I'm sorry. Magnitude defines the amount of quantity, while unit represents the nature of quantity. Now let's give an example to show what is meant by magnitude, what is meant by unit. For example, there's a 10 kg water. If I increase the amount up to 20 kg, the amount is increased. It means that when you increase the magnitude, the amount is increased. Simple logic, no confusing thing. But if you say that if instead of kg, if I use 20 meter, if I use the unit meter, so it was kg, the kg was representing the mass. But when I change the unit to meter, so meter basically represents the length. So entire quantity is changed. You can say that the nature of quantity is changed. When it was 20 kg, it was a mass. But when it's 20 meter, it is basically the length. So when you change the unit, you change the nature of quantity. When it was mass, it has different nature. When it is length, it has completely different nature. So magnitude represents the amount of quantity and unit represents the nature of quantity. Let's go back into the topic. I was questioning you something, that this water is of 10 kg. What is the direction of 10 kg? You may say that it is an irregular question, it is nonsense, you are completely mental, abnormal. You can say many things about it. But remember, I accept that this is illogical question. Why? This quantity contains magnitude and unit. Therefore, it is completed. No more direction is required. So if any physical quantity only deal with magnitude and unit are called scalar quantities. You will learn more definition, you can understand more. Let's begin with another example. For example, there is a student in the building who is running with the 10 meters per second velocity. This is the velocity of the student which is running in the building. I said to another student that please, let's example James. James is a student who is running with 10 meters per second, and Kevin is another student, and I am saying to Kevin that follow the student, catch the student, because he is running in 10 meters per second. Let's suppose, I will again tell you. For example, a student James is running in the building, is running in the corridor with 10 meters per second. I said to Kevin that catch him, because he is running in with 10 meters per second velocity. Kevin asked the question, in which direction is the James running? Let's suppose if I don't tell him a direction, James is running leftward, Kevin would run in rightward direction, because I didn't tell him the direction. I just said him that he is running with 10 meters per second. Go and catch him. So Kevin is asking to me, but in which direction do James is running? If I neglect, I say no, just go. I'm not telling you the direction. So James will go in another direction, and Kevin does not know where the James is running, so he will move in another direction. They will never catch each other. Because you look at it, 10 is magnitude and meters per second is unit, but still this quantity is incomplete because it requires direction. If I don't tell Kevin the direction, he would never catch James. So if I tell Kevin that James is running on the left of the corridor, then Kevin will know what is happening. Then this whole physical quantity is completed. Because without direction, Kevin would not know where James is running. When I tell him the direction, Kevin knows where James is running. That's why he will catch the James. So let's see that if I deal with only magnitude and unit, you cannot define this quantity unless you will add a direction into it. And when a physical quantity is specified on magnitude, unit, and as well as direction, then the definition of the physical quantity is called vector quantities. This is the difference between scalar and vector. A scalar only deals with magnitude and unit, while vector quantities always deal with magnitude, unit, and direction. For example, this mass does not have any direction. It's a scalar quantity. Length is a scalar quantity. Let's say volume, area, density, and there are many physical quantities which are scalar. And what are vectors? Let's say velocity, momentum. For your easy, momentum. For your easy, you can say force. You can say acceleration. So these are vector quantities and they represent magnitude, unit, as well as direction. So in this video we have discussed scalar quantities and vector quantities and the difference between them. So whenever I hope you would love my video. If anything that I have missed by saying something that you don't understand what I am talking about, so you should comment in my video. I will try my best to teach you all. So I hope you will love my video. Please subscribe to my channel, please like my video, please comment my video for more good thoughts, and please share my video. Press the notification bell icon for more info, for more videos that I have been launching on physics. As usual, take care. Allah.